Power rules. Raising a power to a power. To raise a power to a power, you multiply the exponents, and the base is going to stay the same. When you are raising a power to a power, your problem is going to look like this. Notice in parentheses, I have the power 2 to the third power, or 2 cubed. And outside of the parentheses, I am raising it to another power. In this case, it's to the fifth power. You are going to always have parentheses when you are raising a power to a power. Some examples. If I have 5 cubed, or 5 to the third, in parentheses, raised to the negative second power, my 5 is going to stay the same, and I'm going to multiply. 3 times negative 2 is negative 6. So I have 5 to the negative sixth power. Remember though, generally speaking, we're always going to want to write our answers using positive exponents. So instead of 5 to the negative sixth power, I can write it as 1 over 5 to the positive sixth power. The next example, I have 12 to the negative third, in parentheses, to the negative second power. This is a power to a power. I need to leave my base 12 alone and multiply negative 3 times negative 2. Well, negative 3 times negative 2 is a positive 6, so my answer is 12 to the sixth power. The next example, I have 10 squared, in parentheses, to the ninth power. My base of 10 is going to stay the same, and I'm going to have 2 times 9. My exponent, 2 times 9, becomes 18. So my answer is 10 to the 18th power. I'm also going to be able to raise a product to a power. Remember, a product is a multiplication problem. To raise a product to a power, you're going to raise each factor or each thing that you are multiplying to the power. When you are raising a product to a power, your problem will look like this. Notice inside of my parentheses, I have a multiplication problem. So you have a product, and on the outside of your parentheses, you are going to have a power. Just like when you were raising a power to a power, when you're raising a product to a power, you will always have parentheses. Some examples of this. The first example, I have 10x, in parentheses, squared. The product is 10 times x, so my factors are 10 and x, and I'm raising it to a power of 2, or I'm squaring the whole thing. In order to raise a product to a power, I need to take each factor and raise it to that power. So in this case, I'm going to square both 10 and I'm going to square x. When I'm simplifying these, I want to go ahead and square my numbers, and then my variables are going to be left as powers, or the variable to the raised to an exponent. Because I can go ahead and square 10, I'm going to do so. So 10 squared is 100, so I have 100x squared. The next example, I have 4u to the fifth, in parentheses, and then squared. My two factors in this case are 4 and u to the fifth. I need to go ahead and square both 4 and u to the fifth. I'm still going to use my power to a power rules when I'm bringing in my squared to each factor. So in this case, I'm going to have 4 squared and then u to the fifth squared. Well, 4 squared means 4 times 4, which is 16. And then u to the fifth in parentheses squared means I need to multiply the exponents 5 and 2. So I get 16u to the 10th power. In my final example, I have 2a cubed b in parentheses and then cubed. In this case, I have 3 factors inside of the parentheses. I have 2, I have an a to the 3rd power, and a b. What I need to do is I need to cube each one of those factors because 3 is on the outside of my parentheses, or cubed is on the outside of my parentheses. So I'm going to have 2 cubed times a to the 3rd cubed times b cubed. Well, 2 cubed means 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, so 2 cubed is 8. My a to the 3rd power and then cubed, I need to multiply the exponents and I get a to the 9th, and my b to the 3rd stays the same. So this simplifies to 8a to the 9th, b to the 3rd.